Let's now explore another force, tension. One important force for us to understand and understand well is tension. Tension is important because we see it every day in use of machines and so on. When a cord, a rope, or a chain pulls on an object, it's said to be under tension, and the force it exerts is called a tension force. We denote this as F with a subscript T to denote tension. The tension force is the same throughout the cord, rope, or chain whenever that cord, rope, or chain is assumed to be massless. An object that is hanging or suspended is considered to have tension acting upward on it. Any object that is being pulled is considered to have tension acting on it. Unlike gravity and frictional force, there's no special formula to find the force of tension. We need to use free body diagrams and our net force equations to find it. The best way to do this is to have a look at an example. Here's an example of how to find the tension. A 25 kilogram lamp is hanging from a rope. What is the tension force being supplied by the rope? We have a little bit of information here. One, we're given that the mass is equal to 25 kilograms. It's hanging from a rope. That means it's not moving and it's certainly not accelerating, so we have that the acceleration is 0. And now we're being asked to find the tension force on the rope. Let's start off by drawing a little picture. Here's a crude picture of a lamp, and we have two forces acting on it. One is the weight of the lamp pulling down. The other is the force of tension in the rope pulling it up. So let's draw this as a free body diagram. Simple dot for the lamp, arrow pointing downward for the weight, and pointing upward an equal amount, a vector to show us the force of tension. And again, we'll just mark that our acceleration is 0. To solve this, we'll start with Newton's second law. The net force is equal to mass times acceleration. But we know that the acceleration is 0, so we'll set that. Now what about the net force? Well, there are two forces acting here, an upward tension force and a downward weight. So we'll just write these down. Tension up, weight down, and it's equal to 0. So adding mg to both sides, we get force of tension is equal to mg. Now, to find the values, we'll just plug in the numbers. M is 25 kilograms, and g, as we know, is 9.8 meters per second squared, and the result is 245 newtons.